let's define a term. Let's see the definition of the term called adjoint. Adjoint of a matrix. Okay. So what is adjoint of a matrix is, if you have a square matrix, let us say we have a square matrix A equal to n by n, right? Now create a new matrix where you replace every element of the original matrix by its cofactors. Okay, then let's call that matrix as B. Then if you take the transpose of such a matrix B, then the result is called adjoint of the original matrix, edge matrix. Okay, edge of A. So what I mean to say is, we have a matrix. See, one more thing, this adjoint and their inverses, they can be done only for the square matrices. Keep that in mind. Adjoint, inverses, determinant, everything, all these are applied only for the square matrices, not for the other matrices. Now let us say A is a n by n square matrix. Of course, n by n is square. Then what I am trying to say is, take that matrix and replace every element of that matrix by its cofactors. Then get the resulting matrix, let's call it B, and you find out the transpose of it. Once I find out the transpose, then that such a matrix is called adjoint of A. So adjoint of A equal to B transpose, where B is nothing but the how we obtain is by replacing every element with its this cofactors. Got it? Now look at the theorem. If capital A be any n-row square matrix, then edge A into A into edge A equal to det A into In, where In is n-row square matrix. It is very important proof because theorem, because from this theorem we are going to define the inverse of a matrix. Based on this one, we can say that a matrix is going to have inverse or not, and how to find out the inverse of a matrix. Okay, so let's see this. Let's see how it is true. So what they are trying to say is, if A is a matrix which is a square matrix, find out the adjacent of A, adjacent matrix of A, adjoint matrix of A, right? And after finding out the adjoint matrix of A, multiply that adjoint matrix of A with A, or A with the adjoint matrix of A. Then the result is nothing but taking the identity, In is the identity matrix, taking the identity matrix and multiplying with the determinant of A. So how is it possible? I'll just show you. Let's take just a small example. Let us say A is a small matrix like this, 3 by 3 matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33. So A is a small matrix, 3 by 3 matrix, right? And now find out a matrix B, and B is obtained by replacing each element of A by its cofactors. Let us say the cofactor of each element, the cofactor of element small a11 is capital A11, and the cofactor of the element A12 is capital A12, capital A13, capital A21, capital A22, capital A23, capital A31, capital A32, capital A33. Okay, so this is the cofactors. This is the matrix obtained by taking the cofactor. Now if I take the transpose of this matrix, then that is called as adjoint of A. I will multiply this with the transpose of this. Okay, this transpose is nothing but A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, so this is a matrix and this is the adjoint of that matrix. Now multiply these two, then see what do we get. A11 multiplied with A11. See, I'm just writing the result here. I'll just write the result here. Okay, so the multiplication of these two matrices, the multiplication of a matrix with the adjoint of that matrix, I'm just going to write it here. Okay, now if you observe it, A11 is multiplied with small a11 capital A11 plus small a12 capital A12. Are you understanding it? It is row by column multiplication, right? plus A13 capital A13, right? And similarly here the second element is going to be this row multiplied by this column. Okay, now if you observe it, this row multiplied with this column is nothing but actual value, the definition of the determinant. What is the definition of determinant? Multiply every element with its corresponding cofactor and then sum them up. Therefore if you observe this entire thing is nothing but determinant of A. So I am writing it with det A. Got it? See, this row when multiplied with this column, it is nothing but multiplying every element with its every element of the row with its corresponding cofactor and then summing them up. That is nothing but the definition of determinant of a matrix. Therefore I can write it as det A. And now if you look at this one, the next this element 1 2, you have to take the first row and second column. It is nothing but A11 multiplied with A21, A12 multiplied with A22, A13 multiplied with A23, which is nothing but multiplying all the elements of a row with the corresponding cofactors of a other row and then adding them up. We know that by definition of the by the definitions we know that it is 0, right? So whenever you multiply the elements with the corresponding element cofactors of a different row, then it is going to give you 0. So here it is going to be 0. And the same thing will happen with A13. A13 is also nothing but multiplying the first row elements with the cofactors of the third row, right, which is nothing but 0. And this element is 2 1. So 2 1 is nothing but multiplying the second row with this first column, which is nothing but the cofactors of the first row. So multiplying second row with the cofactors of the first row, which is again going to give us the 0, right? And then A22, this element is nothing but multiplying second row and the second column. So if you observe them, they are actually they are the elements and their corresponding cofactors, which is again nothing but det A, right? So likewise you can see that this is what we get. So which can be written as det A into I3, right, which is 1 0 0 0 1 0 0 0 1. Okay, so this is the this is what we got, det A into IN. So I think you understood this, right? If you take the adjoint of a matrix and then multiply with the matrix, or you can even perform the reverse way. Take the here I have taken a matrix and then adjoint. You can even multiply it in the reverse way, which is nothing but adjoint of A and A. It is going to produce det A into IN. Okay, it is very important. We shall see some examples on this. We'll understand it better.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.